Every prompt sent to ChatGPT travels straight into a massive, intensely hot room packed with thousands of high-performance servers, working furiously to calculate a response. Now multiply your single prompt by the hundreds of millions of queries users submit every day. To process that staggering volume of data, the entire artificial intelligence industry relies almost exclusively on hardware built by exactly one company. NVIDIA, led by CEO Jensen Huang, holds a near monopoly over the AI data center ecosystem. But relying entirely on NVIDIA comes with a heavy financial toll, known in the industry as the NVIDIA tax. Companies swallow exorbitant hardware prices, manage extreme power consumption, and wait out severe supply bottlenecks just to get the chips they need. For an AI company trying to scale quickly, this absolute dependency on a single third-party supplier creates a massive operational roadblock. This chart shows OpenAI's daily user growth alongside hardware expenses. As ChatGPT users climb exponentially, the physical cost to run queries spirals alongside it. Eventually, the math stops working. Relying on expensive third-party chips limits growth before a company literally cannot afford to operate. To survive the success of their own software, OpenAI had to pivot. Under Sam Altman, they decided to start building the physical hardware themselves. The result is the Jalapeño intelligence processor. OpenAI partnered with Broadcom to design it and tapped TSMC to manufacture it on a highly advanced 3-nanometer process. To understand why this specific chip exists, we have to look at the core divide in how AI actually operates: training versus inference. Training is the brute force phase where an AI learns how to think by crunching massive datasets. It requires highly versatile hardware, general-purpose GPUs, which is exactly what NVIDIA excels at making. Inference, on the other hand, happens after the model is already trained. It is the lightweight, single-task process of taking your specific user prompt and generating a perfectly accurate text response. This diagram illustrates why using a general GPU for inference is inefficient. It is like using a heavy, complex multi-tool when you only need a single screwdriver. Jalapeño is an ASIC, which means it is permanently hardwired to do exactly one thing: inference. By stripping away all the general-purpose features required for training, OpenAI created a specialized chip that drastically undercuts NVIDIA's power draw and per-chip costs. What is particularly alarming for the rest of the industry is how fast this happened. Traditional silicon design takes years. OpenAI built Jalapeño from scratch in roughly 9 months. They achieved that blistering speed by using their own AI software models to aggressively accelerate the hardware design process. This chart lays out a fascinating new loop. We now have AI software generating hardware schematics. That new hardware then powers even stronger AI software, which in turn designs even faster chips. The Jalapeño chip is one piece of a broader, coordinated industry siege against NVIDIA's dominance. Google has been pushing into custom silicon for years with their Tensor processing units. Meta is rapidly deploying their own MTIA hardware directly into their data centers. And Microsoft recently introduced their Maya custom silicon to complete the map of defecting tech giants. This collective movement is a race for vertical integration, a strategy where a company owns every step of its product pipeline, rather than relying on outside vendors. These tech giants have all arrived at the exact same conclusion: controlling the entire stack, from the software code down to the physical silicon, strips away the external bottlenecks that would otherwise slow down their growth. NVIDIA still builds world-class technology, and they will be essential for training future models. But their run as an unavoidable monopoly is coming to a close. The Jalapeño processor removes OpenAI's reliance on an outside supplier's pricing and production schedule. This shift in the industry landscape shows that the software makers are now building the physical tools they need to scale.